Okay, well, here we are at polynomials, and if I have my timing correctly, you're either watching this on Monday or Tuesday. I hope things are going well enough. I'll come back and answer any questions that you guys might have and make sure we're in a comfortable place before we move on. But here's a nice little warm-up based on what you did in class yesterday. I hope you guys worked together and figured some of these things out. Here we're trying to just basically find where the like terms are. The like terms are where the variables and the exponents are the same and to the same degree. So what I mean by that is x squared y, the only thing I can add to that is another x squared y. And here's another x squared y over here. Here I have x cubed y squared. Okay, that's obviously not the same, but over here I do have an x cubed y squared. So if I add the x squared y's together, I get 7x, oh, wait, subtraction. Nope, caught myself. That's a great way to start out. Okay, so 3x squared y, and then now I have x cubed y squared, so 7 plus 1, both positive. Making sure I pay closer to attention this time. X cubed y squared. Notice that the variables and the exponents stayed exactly the same as they were in the originals. When you're adding like terms, those variables stay exactly the same. 1 apple plus 2 apples is 3 apples. Okay, it's only when you multiply these terms together that you change the exponents. Alright, there we go. And we're going to do a lot of playing around with polynomials over the next week or so, and it starts right now. So we're just going to be multiplying a whole bunch of different polynomials today, and that's what our lesson is basically on. Multiplying polynomials. And so here you see I have a trinomial, 1 terms, 2 terms, 3 terms. So I have a trinomial, and I have 2 terms here that is known as a binomial. So I'm going to multiply a trinomial times a binomial. I like to put it so the smaller ones are first. So put the binomial first, and then the trinomial after that. So you can see that the true operation going on here is multiplication. And so when we're multiplying polynomials, it's really just the distributive property over and over and over again, and then you combine like terms. Remember, the distributive property says that a number multiplied by the sum of two numbers is equal to the number times the first plus the number times the second. The distributive property, oftentimes teachers will draw the arrows saying multiply by both of those. But you know, the distributive property holds not just for a monomial times a binomial, it holds for a monomial times a trinomial as well. And so instead of adding these all together and then multiplying by a, I might choose to just multiply a by each one separately and then add those together. That's the distributive property. So when we do polynomial multiplication, we're simply using the distributive property over and over and over again. So let's see what that looks like here. So I'm going to take the first term in the smaller polynomial and multiply it and distribute it into each of the 3 terms of the larger polynomial. So a times 2a squared we have as 2a cubed. Alright, so I've done that. Now a times negative ab is going to be a negative a squared b. And then lastly for this one I have a times positive b, so that's positive AB. Now I notice I'm going to run out of room here, so I'm actually going to drop it below for my next one, and I'll show you what I mean. So now I'm going to do this negative 2b, or not to be, and I'm going to multiply it by each term in the trinomial. So negative 2b times positive 2a squared is negative 4a squared b, So I'm going to put it underneath this other a squared b. Now I'm going to do negative 2b times negative ab, so that's going to be a positive of ab squared. I don't have any other of those. ab squared, so I'll put that all the way over there to the right. And then lastly, this negative 2b times positive b is negative 2b squared. Don't have it anywhere else either. So let me see if I can shrink this. First I'll group it. Sorry, you guys have to watch this. You shouldn't have to. Group. Now let me see if I can get that out of the way. Alright, back. Oh, no. Here we go. Pen, blue, and then negative 2b squared. Alright, now I'm basically just going to add my like terms together. So let's go black, drop down, 2a cubed. Combine these like terms, I get minus 5a squared b. And then I do want to go in order of degree, so ab squared is next. And then I'll come over here to plus ab and then minus 2b squared. Alright, so I believe this would be my final answer if I was multiplying this binomial times this trinomial. 1, 2, 3, 4, 5 terms. Makes sense. Alright, hope that went okay because we're going to be doing a lot of that today. And we're going to be talking about special cases of multiplying polynomials. So here are some of the objectives we're going to have. Why don't you put me on pause and start writing down a couple of these right now. Okay, so multiplying any two polynomials, and specifically multiplying two binomials is going to be one of the things that we talk about. So two binomials, that's something as simple as a plus b times c plus d, and how that equals ac plus ad plus bc plus bd. I haven't been using my space very well. Squaring a binomial is a special case we'll talk about. Squaring a binomial would be, hey, I have a plus b squared. And so what does that look like when I'm done? Well, that's a plus b times a plus b, which we end up with a squared plus 2ab plus b squared. If you FOIL that out, or double distribute as I like to say. Multiply the sum and difference of the same two terms. That would be an example of, hey, I have these terms a and b. I want to multiply the sum and the difference of these two terms. And if I do multiply that out, double distribute, I end up with a squared plus ab minus ab minus b squared. And you see when I combine my like terms, the middle terms cancel out. Isn't it amazing? One positive, one negative, they cancel. So I end up with a squared minus b squared. And then the last thing I have is cubing a binomial. So here's a binomial. I want to cube it. So I end up with a cubed. And I'm not going to go through the whole process. I'm just going to show you what the final answer is. Plus 3a squared b plus 3ab squared plus b cubed. So that's what I get when I cube a binomial. And we'll do a lot of practicing over the next 7 minutes or so. Alright, I hope we're ready to move on. Let's go. Okay, here we have a binomial times a binomial. Two terms times two terms. So for me to start this process, I'm going to take this first term, 3x, and I'm going to distribute it into every term over here. So into these two terms. 3x times 5x. 3 times 5 is 15. X times x is x squared. And now I have 3x times y. Both positive, so I end up with 3xy. Now I'm going to continue to the 2y. I'm going to multiply the 2y into each term. I'll distribute it into each term. 2y times 5x. 2 times 5 is 10. X times y is xy. Generally, we prefer alphabetical order, so it's easier to know when we have like terms. And now I'm going to multiply the 2y times the y, and I end up with positive 2y squared. Now when I look at this, I look at my terms, and I identify any like terms, and I identify 3xy and 10xy as like terms, so I'm going to go ahead and group those together and end up with 15x squared plus 13xy plus 2y squared. My final answer is a trinomial, and that makes sense. Alright, so that's what we're going to be basically doing, is distributing over and over and over again and picking up some patterns of these along the way. So multiply 2xy plus 3x times 4x minus 1. You should have 4 terms, I think, when you're done. 4 terms. Give it a try. Okay, so I've color-coded which multiplication resulted in which term, and we do end up with four terms that are unlike, so we're not going to be able to squeeze any of them together. So final answer, 8x squared y minus 2xy plus 12x squared minus 3x. And notice I go from 3 degrees, 2 degrees, 2 degrees, 1 degree. When you have two of the same, if you have anything that's just squared, then you put that at the end. Okay, another binomial times a binomial. If we end up with any like terms, we'll squeeze them together. Otherwise, we should have four terms when we're done. All right, give it a try. Okay, I hope you had enough time to do that before this popped up. We do end up with four terms. Degree 4, degree 2, degree 5, degree 3. Oh, my order is way off. I have to change my order around. Alright, so what's this going to look like when I'm done? Degree 5, 3 plus 2 is 5. So 2x cubed y squared. Here's degree 3, here's degree 4, plus 6x cubed y minus 4x squared y minus 12x squared. Alright, there's my final answer for that one. Four terms, descending order, leading coefficient of 2. Polynomial has a degree of 5 altogether. Alright, moving on. Sometimes you see the directions for multiplication as simply multiply. Sometimes you see the directions as expand, and that would be the directions when you're just given a polynomial and then raised to an exponent. So here we're asked to expand the quantity x plus 4 squared. So we should know that this is equal to x plus 4 times x plus 4. But I'll tell you what, if you're one of these people, please try and pay attention to it. And when I say these people, I mean those who think that the square distributes to the x and the 4, and you get x squared plus 4 squared, and you're done. No, that is not the final answer. If I could take one of these smiley faces and turn them upside down. Boo, no, don't do that. Does that work? Don't do that. You're missing the middle terms. You're missing the middle terms if you do that. As we know, when we multiply polynomials together, we have to distribute. So we'll get x times x, which is x squared. But then we get this 4x, and then we get another 4x, and there finally comes the 16. X squared plus 8x plus 16. If you do this, you're missing the 8x. You can't miss the 8x. Don't do that. Here's a visual of what I'm talking about. So when you multiply polynomials together, you can represent them as lengths of sides and eventually areas when you're squaring something. So here we have a square whose side length is x, and you can see I have x over here, so x, and altogether the area of this square is x squared. Then I also have these bars here, these green bars, and this is a length of 1 right there, and this is a length of x, same as it was up here. So here we have 1 times x, and so we have an area of 1x. And so this is a length of 1, 2, 3, 4, because I have 4 green bars. So altogether, this is x plus 4. And I have the same thing on the other side, because I'm squaring it, right? I'm turning a length into a square. And when you turn a length into a square, you're now measuring the area. So when I do x plus 4 squared, that's x plus 4 times x plus 4. Find the area of the square. So to find the area of the square, I can find the area of all the little pieces that make up the square. So I have x squared here. I'm going to add 1x, 2x, 3x, 4x, 5, 6, 7, 8 x's. That's the part we're missing. And then here we get the 16. This 1 times that 1, these all give me different 1. So 1 plus 1 plus 1 plus 1. I counted them all up. There are 16 of them. When you square a binomial, it's x squared plus 2 times the first times the second, and then times the last one squared. That's the pattern. Alright, I think I'm going to have to continue this video on to the next one. Sorry to make this a two-parter, but there's lots of multiplying to be done. I'll catch you in part 2.